Okay, so sometimes the reverse chain rule strategy doesn't always work, and so you need to actually come up with a different strategy to integrate some of the more complex ones, because you don't exactly wish to expand this 3x plus 1 to the power of 4. Although if you want to, it's also a valid strategy. So what we want to say is, hey look, we actually do know how to integrate u to the power of 4. Yeah? So we kind of just want to say, well, what is u? That's quite clearly 3x plus 1. Okay, so if we said u is 3x plus 1, we want to integrate, but we've been told at the moment we want to integrate dx, but I want to integrate du. So I need to have a formula that says what dx is. If I differentiated this function u equals 3x plus 1, I get du dx is 3. So that can, if I rearrange that, du equals 3 dx, so dx must equal du over 3. So where I had a dx, I'm going to put a du over 3. Okay? So now I'm just going to integrate this as per usual. I raise the power by 1, u to the power of 5, and divide by the power, I get u to the power of 5 divided by 15, plus c. And then the last step you want to do is just substitute u back into, so 3x plus 1 to the power of 5 over 15 plus c. Okay, and that'll actually put you in the position where if we differentiated this, it would give you exactly what you want. Okay, now that actually probably could have been done as a reverse chain rule question, but it's a good starter example of how to use integration by substitution. Okay, this next one we couldn't actually use reverse chain rule because this power of x, the x there, by itself is actually one less than the one on the outside. We want it to be the other way around. So that reverse chain rule is not going to work. So let's do the same thing. Now the strategy is I'll try to let u equal the more complex thing. X squared by itself, making u equals x squared is an option, but the better option becomes using u equals x minus 3. You'll develop the choice selection of what u is by doing a lot of problems. So you need to do the whole exercise of integration by substitution, and it will pay to do a revision session on it towards the end of the year by yourself doing similar revision questions. Okay, so that means du dx here equals 1. Now look, note I'm laying this out exactly the same. I always write on the right what u is, what du dx is, what dx is du, and then I substitute that in. So that always happens. So I've got integral of x squared u to the power of 4 du, because du is dx. Now the problem is x squared is not, in terms of u, I can't integrate this. So the other thing that I always do on the right is I try to get a formula for what x is. Here x is u plus 3. It's u plus 3 because of this formula up here, u equals x minus 3. We rearrange that. So I put u plus 3 where there is an x to the power of 4, integrate du. Okay. Now this here we can actually, it's a lot simpler. We'll expand, give us u squared plus 6u plus 9 times u to the power of 4 du, u to the power of 6 plus 6u to the 5 plus 9u to the power of 4. If we want to integrate that, that's really simple. We just go u to the power of 7 over 7 plus 6u to the power of 6 over 6 plus 9u to the power of 5 over 5 plus c. And the final step is to substitute that x minus 3 back in where there was a u. So replace each u with an x minus 3. So there's an x minus 3 there. And you want to replace that u with an x minus 3. Well, that's all right. 6 divided by 6 is 1, so we can get rid of that divided by 6. X minus 3. And then where there's u is here, we put an x minus 3. Okay? And then we've actually got ourselves the solution. Okay, so you're integrating in terms of u, that function, and then you're substituting x in. Okay, so if we kind of just went through the rules, let's do a step by step. I'll write these underneath. Substitute u for the most complex thing. So, for instance, here we substitute for 3x plus 1. Differentiate u to get to u dx, rearrange to get dx, what dx is, so that's there. Then, if necessary, rearrange for x equals. Okay, substitute them both in, so where there was a dx, we put a du over 3, so that's there. And then, where there was a x, we ended up putting a u plus 3, so that there it was an x, so we put a u plus 3. Okay.